Hello, this is Sam Hunter. Today I'm going to be doing a science experiment for a 5th grade NGSS standard. The standard is from the domain of physical science and it is number 1-4. It's for them to conduct an investigation of 2 different substances to see if they will mix or if they don't mix, and then of course why. So our materials today to make our lava lamp are going to be an empty water bottle. You can have the kids collect these, and it of course incorporates a great recycling project. So water bottles, and then otherwise if you have tons of them at home, save them for a month or so. Oil, I got vegetable oil. Vegetable oil is cheaper, so it's easier, but just about any kind of oil can work. You can have kids bring in oil. And then a pitcher of water or a sink, however you want to be able to fill the bottles. And then I do have food coloring. Just about anything that are color water will work, but this is cheap and it's super concentrated, so you only need a drop. I have, this is store brand Alka-Seltzer, so anything that fizzes should be able to work. This is optional, and I'll tell you why in a bit. And then I do also have a small flashlight. So if you have flashlights handy, it's great. It'll help illuminate the reaction later. So it's not a huge deal. You can still see it without it, but the kids love to see them light up because then it relates it more to a real lava lamp. So before I start the lesson, I would typically show the kids a video of how lava lamps work, maybe some sort of science lesson where they break it down, take it apart, what actually goes into it. And then explain to them that we'll be making our own. We're not using the same chemicals or anything. Ours is not going to heat up like that. But the fact that they get to make something that they see that is so scientific and cool, they get to make it at home, is awesome. So to start out, everyone's going to have their water bottle. Now the proportion of water to oil is not a huge deal. It does not need to be measured or specific, which makes it great, easy to do with a larger class. And then I do put the water in first. And this is something you could pre-fill the bottles with water if that's easier for you. If you have kids that you don't trust as much, you can always do that. Then the oil. I just poked a small hole in the top. That way it's not all coming out at once. It's less chance that we're going to make a mess. And this is something that you can have parent volunteers come in and do if you don't want the kids pouring oil, because it can get messy. And it does not need to be filled to the top, but just about there. Okay, so we have water or oil. Now, before I pour it, I do like to ask the kids what they think is going to happen. Are they going to mix? Referring back to the standards, if 2 substances will mix or not. A lot of them will probably say they will not, just because they've seen it before, but they don't know why. You know, they see their mom cook with it in the kitchen. Some, of course, will say it mixes because they figure it's 2 liquids, and liquids are always going to mix, and that is why we're doing the experiment. So you can see that line in between. Even before I add anything else, I like to have them turn it upside down. See the movement that goes on in there. They love to watch the bubbles. I have even let kids, that for some reason they really want to shake it up as hard as they can. And I let them, but then they have to, once it's shaken up, they have to wait until all the oil goes back up to the top, which I love to watch. But the more you shake it, of course, the longer it's going to take for the water to go back down. So give it a moment, let it go down. Then while that's settling, using the colors is a great way to incorporate art for our STEAM activities. Because they can mix colors. They can use one color, they can mix 2 and see what it looks like. This is, if I wanted to make an orange one, I can take my red and my yellow, which of course you can reiterate our primary colors. And by mixing them, we're going to get a secondary color of orange. So just a little drop. Of course, it's super concentrated, so even something this size should last an entire class. And just a drop of red. Okay. Now, the food coloring sometimes requires a little bit of help to get it down to the bottom, because they like to hang out in little balls. Quick shake will break those apart. And there's my food coloring balls now all spread out. Now this is when this color's a little pink. I'm gonna make it a little bit darker just so it stands out more from the oil. Now, we would hope that kids want to make a cool secondary color like that orange. But of course, some of them want to mix all the colors, thinking that they're going to get lots of little balls, which we have right now. But over time, as those settle, it's just going to turn brown. So it does take a little bit of time to settle. So we will wait for that. Okay, so now that it has just about settled, before I add anything else, I let the kids move it around a little. They can see the mixture in there. This is when it's cool. If you have it, take a flashlight, put it at the base, and then flip it. It really illuminates what's going on there. It's a little harder to see on the screen, but it looks super cool in person. And then if you have it, if you are able to do the Alka-Seltzer tablets, they're in little packets. Now, of course, the whole tablet won't fit into the top of the water bottle, so you can break it up a bit. As much as you can. And open it up. And then the better you crush them up, the better the reaction's actually going to work. So if you can crush it with something else or pre-crush them so the kids don't have to, that would be great. Just pour them in. They should float to the bottom. And then start rising to the top. It's definitely much harder to see on video. But you see the bubbles. Awesome. Now, of course, that creates pressure, which a lot of the kids might not understand yet. So you don't want to have the lid on for very long when you're doing that. But there it is. Now, in order to give modifications for a high ceiling and a low floor, you could have those students that aren't as entertained just flipping the water bottles up and down. They could graph it, so maybe have them shake it up as much as they can, or for certain periods of time, graph the amount of time they shook it up for, and then the amount of time it took it to go back to normal. Because even for this one to get that far back to normal, I did have to pause the video for a bit. But this one was sitting for about 10 minutes, and it's fully back to watercolor and oil. So you could have them graph it. So if they shake it up for 30 seconds, how long does it take? If they shake it for 10 seconds, how long does it take? And other than that, this is something that you can keep in your classroom. Of course, maybe glue the lids closed if you're going to keep them around. And then those kids that need something in their hands all the time, maybe some trouble focusing, give them one of these and let them just play with it. They can look at it. It's fun to touch and feel and shake, and so it's something that you can have to entertain kids that have attention span issues. Other than that, it's something that they can take home, and it's super easy to explain to their family how they made it. You can even send home directions so the parents know that if they add Alka-Seltzer to it, it will react again. Of course, one of the key words in this lesson is going to be density, why the two liquids don't mix. So depending on your 5th grade class, how far into that you want to get would be up to you. But that is how to make a water bottle lava lamp. Thank you so much. Have a great day.